Hello, Lambda Days. The title you can already see, and it was already mentioned, so let's quickly go through obligatory slide about me. I'm Łukasz. I'm a Scala developer advocate currently at Virtus Lab. I dabble in, Scala, obviously, functional programming, distributed systems, and, given the topic of the presentation and the fact that I'm leading the team building Besom, DevOps is also my thing. You can find me on Twitter. That's my handle. And without further ado, let's talk about the agenda of this talk. Let's talk about what we are going to talk about today. So the first question is, obviously, what platform engineering is. And if you were to do platform engineering, how would you do that? So then we will try to figure out how to do that without much pain, how to improve the situation in how you currently do platform engineering. And at the end, we will try to actually use new stuff that is coming to Besom that is available via Pulumi and show how this future might actually look like. So let's start with the first thing. Well, what happened to DevOps? We used to talk about DevOps a lot, right? So apparently it's dead now. And apparently all the spin doctors of the DevOps area have changed the ship. They are currently riding the wave of platform engineering. There's a lot of discussion, mostly in product area, mostly at sales area. Not that much if you look at engineering side of the equation. Mostly because most of the stuff that we are talking about is something that people want to sell. Those are products in cloud APIs, in cloud providers platforms. So I have a definition. I found one. Yeah, that's a product guy from Humanitech company, Luca. So he defines it as an engineering discipline of design and building tool chains and workflows that enable self-service capabilities for software engineering organizations in the cloud-native era, blah, 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 blah. Basically, the gist seems to be that we are going to, do DevOps and automate it. So automate it with basically CI/CD. So I've taken the liberty of asking another expert about that. And he came with basically the same thing. So there are some, questions whether he also helped with all those blog posts that have shown up recently about platform engineering. So yeah, it's basically something that we already know. It's just pushing all the DevOps solutions that we have used recently into CI/CD workflows with triggers that users can then trigger, basically, that users can start. So users want something, starts a CI/CD pipeline, and that builds something for the user. So I have my personal definition, which didn't change at all from the previous definition of DevOps, which is basically that this is what DevOps is. So nothing really new in this area. We are still, juggling fire torches, flaming torches on a unicycle. It's a harsh reality, and well, it's a difficult area that, as a functional programmer, I would like to improve. I would like to see being, more robust, being better, just like functional programming is. So how do you currently do things that are described as platform engineering? So it took me some time to actually find what is being actually proposed in this area under all this marketing blabber. And well, I found this, for instance. That's a design of internal developer platform on AWS. And it seems that it's really wrapping Terraform in CI YAMLs, in pipelines, not something that we would like to continue to do. At least I hope there aren't many people that enjoy that stuff. So question that I want to answer is, can we do better? Can we do something that actually improves our quality of life and helps us build better products? Well, it turns out there is. That's not really surprising given the topic of the talk, but Pulumi is the solution that actually helps us to do this, because Pulumi allows us to use our favorite programming languages that we know, that have all those wonderful properties that we are used to, especially in functional programming. So properties like type safety, properties like code reuse, all those nice properties can be used to declare infrastructural programs that then define the infrastructure that is used by your product. So Pulumi offers quite a lot of SDKs for languages. There's support for TypeScript and, by extension, JavaScript. There's support for Python, Java. There's support for Golang and .NET with the whole ecosystem. So F# is also included. At Virtuous Lab, we have built 2 SDKs, actually free, but Java was adopted. We have built SDK for Kotlin, which is a wrapper for Java SDK, and we have built a full, from ground up SDK for Scala that uses pure functional programming and translates to known and well-used effect systems like Zio, Katz effect, and you can use it with Future if you prefer, but it's still pure functional programming. So very briefly, let's go through how those things look like. So Pulumi operates on stacks. When you write a Pulumi program, it becomes a blueprint. It becomes something like a class in programming languages. You have to instantiate it. You have to create an instance of a blueprint, and that's what a stack is. Stack is a program that has been evaluated and built some kind of environment, some kind of infrastructure. Pulumi operates on resources, inputs, and outputs. Resources are things that you define as something that you want to happen, something that you want created or deleted if you remove it in the infrastructure. And resources takes those args classes. Can you see that? Yeah, you can see that. I probably should just use that, I guess. Oh, it doesn't work. So args classes take inputs. Inputs are properties that you want to feed into resources to create them. So all the configuration that you want to provide to any resource goes into the args class. That's an input, and it's an elastic API. You can push plain values, like plain strings, plain integers, into inputs. You can also provide dynamic values that have been taken from another resource that is going to be created when you run your plan. So outputs are those properties that are bound to resources that are going to be created in the future. So when you create a resource, let's take a look at a small example here. When you look at this, we have 2 S3 buckets, nothing really interesting. But what is important is that the website endpoint property on the cats bucket and dogs bucket is an output. It's a property that is going to happen in the future. It's going to be fulfilled in the future. Okay, so basically a monad. So this is how a very, very small Besom/Pulumi program looks like. Now, if you would like to get some more information about that, how Pulumi works, there's a very short, very nice video available under this QR code. Very good for morning coffee, and if you are completely broken mentally by doom scrolling on Twitter or on TikTok, if your attention span is short, it's only 3 minutes long. I really like this video. So let's talk about how would platform engineering look like in the world of Pulumi. I've taken the liberty to lift this small chart from the website of Pulumi because it basically shows us the difference. So when you are using Pulumi as a tool like CLI in your usual work, you are on the left side of this chart. So you are just a user running Pulumi CLI on your machine. The same can happen in your CI/CD pipelines. That's also what you get with Terraform if you are using Terraform from CI/CD. But the good stuff is on the right side. So you can use Automation API, and you can embed Pulumi programs into your programs. And that's a very big shift, because what it means, you can create services that interact with your users, basically your products. And then those services can manage infrastructure on their own. And you have full control over what they do, because you provide those Pulumi programs that serve as those blueprints for stacks that will be created. So I have a practical example. Weird. We thought that it wouldn't shut down, but it did. I have a practical example, and I wanted to ask, are you familiar with this company? Do you know Netlify? Cool. Netlify showed up on my radar first as a company. I think they are doing more stuff now, but they showed up my radar as a company that massively simplified deployment of static websites. So if you had a site, bunch of HTML files generated by some static site generator, usually Netlify had this small, nice button in GitHub that allow you to, just click it and it would deploy the whole thing to Netlify, and you would have it available. You could, just go to this URL and it would be there. So that was very nice. I like this very much. So I've decided to build a clone, and I was very curious how much time it will take to do this with Pulumi Automation API and with Besom. So I've taken the liberty of, making those goals that Netlify has, making them a bit smaller, so that I don't have to spend half a year to build this. So I just wanted to host static content only, no fancy stuff, so no script running on the server side. I only wanted to provide dynamic provisioning of resources for users' websites on demand, so what we would basically call a self-service approach. So you come to the website, you just put some stuff into that, you just press deploy, and it should just show you a website that contains your HTML. And you should also get a nice URL that you can forward to from your domain, or just share this domain with your friends. So we could start with working on that now, but that would kind of take more time than we have. So it took me about 48 hours, I think, to build Scalify. And sorry for the not really precise domain hack. It seems that there is no TLD, that is just phi. So I had to make do with what I have. And I'm going to share the deployed application with you in a moment, but there are some reservations, because it's just a POC, and don't worry about costs. There are no costs involved for me, but I just worry that it will break and demo effect. So don't click the deploy button twice. I think I solved it an hour ago. I'm not sure. You will have a box to enter a subdomain that you can use, and well, basically it will be the first segment of the domain, subdomain that will be used. I have no idea whether a full UTF-8 works. I don't think so. Don't try putting emojis into that. But you should be creative. You should come up with something unique, because it will crash on duplicates. Or, I think I also fixed that about an hour and a half ago. It will override and overwrite someone else's website. So don't use test, for instance. Or don't use first names. You can put any HTML into the context box, and it will be the index.html file in public internet. So, be wary. No nasty stuff. And yeah, click deploy once when you have put all the input into that, and we will see. We will hope that it works. I tested that, but you know how tests work. Okay, here's the link. If you are interested, you can go there. You can also just go there. It's just Scala for your information, FYI. And you can do whatever you want with that. That's exactly what I'm going to do right now. So I have this piece here. That's the whole website. Don't blame me. I'm not a front-end developer. There's something called Tailwind. I've used that. So it's not very horrible, but it's obviously quite horrible. And yeah, it uses HTMX because, you know, we have to be on the meme wave. I think the HTMX meme wave is passing, but well. And let's see what happens. So this is the Pulumi Cloud dashboard that I'm using. Let's hope that it didn't log me out. Oh, wow. Okay. Things are happening. People are deploying stuff. I'm not sure whether everything will go well here, but let's see. So we can go to, oh, there are no updates. Apparently there's some limitation on parallelism. I didn't check what is this limitation. So let's see, deployment of I love pierogi, which is, I also love pierogi, so this one is fine. Okay, so we can see in cloud what is happening in our deployment, which is happening in a pod inside of Kubernetes cluster. We'll get there in a moment. But anyway, this is happening. I just wanted to show, but it takes a minute. Okay, let's not waste time. Let's go back to the slides. Let's quickly talk about the architecture of what I have done. So this abomination of cloud engineering that I have done runs on a single head snare VM because it's cheap. Then I have put K3S cluster into that because Kubernetes is an awesome solution to any hair problem. If you have Kubernetes, you won't have hair, just like me. So I fully, approve using Kubernetes for single node deployments. And then we have some, of the stuff that has to run inside of Kubernetes. So we have an ingress. This ingress has two rules for routing. One takes a wildcard for subdomains, and the second goes to the root URL. That is our application, written in Scala that manages the infrastructure using Pulumi automation API. The subdomains are handled by plain Nginx deployment, nothing fancy here. And what we use in a rather hacky way, I forgot to put Minecraft hatchet here, sorry. So we have a shared volume. Basically, we have a shared directory on the server where all the deployments that we're going to do are going to live just as folders, then Nginx can load them. We could scale this up pretty easily. We will just need to deploy a distributed file system, something like Longhorn, and then it's just a matter of increasing amount of replicas for everything. And it should probably just work, out of the box. So the last bit is that the application also manages something that is not in the cluster. So we have connection to Cloudflare, which does provide configuration for our main domain, Scala, for your information, FYI, goddamn. So it provides routing, those DNS A records that are required to route the traffic to our cluster. So that's the whole thing. It's not more fancy than that. And interesting bit is that Pulumi stacks can have dependencies between them. So this is actual architecture of how this looks like from Pulumi's perspective. We have a platform stack, which declares the VM and K3S that is deployed onto the VM. We have a stack that contains site, which is Nginx deployment, application, ingress, traffic control, things like that. And then Then there's the bit that we have just seen in the, oh no. Let's see how wrong are things going here. Oh, they aren't very, oh, somebody did that. Yeah, I feared that somebody will do that. Okay, but we have something here. Let's say, haha. We can check what is going on with haha. Okay, it says it deployed successfully. Okay, so you can see here that this is one of those small user stacks. They have dependencies on both platform and site stacks. They pull some properties out of them. So basically arguments for the function that the stack is. And if we go here now, can I go there? Is it safe? Okay. Will it work? No, not really. God damn, it's still not deploying. Okay. It seems all of you have won the race. What's happening with this? I think we killed it. Okay, let's continue. Maybe it will come back. Anyway, so what we have here is the infrastructure in which properties in one stack are pulled via the construct called stack reference from one stack to another, and then reused to hydrate all the necessary properties to configure stuff. Let's go through the code. So the whole repository is here, and you can see there are full folders. Application itself here. It could be probably more readable now. There's platform, which is basically the deployment of Kubernetes and virtual machine. Site, all the application layer stuff, and template, something that we use for actual deployment of whatever people have tried to deploy, and let's see whether that worked. So we have one successful deployment, and I have no idea what is happening with this stuff. It's still hanging. Okay. Okay, this seems it has deployed. Timeout occurred. 404, awesome, it failed. So this also doesn't work. Yes, demo effect in full scale. This was Ivan Industrial. Oh, yes, this one went through. Cool. Okay, at least one didn't fail. So I see that the only change that one person did here is one of the chevrons was removed. Okay, I don't blame you. You just click deploy. Either way, this is the deployed stack. So let's go through the code quickly. I don't know how our timing looks like. Oh, it's pretty well. It's even better than I expected. So let's start with platform. Platform is fairly simple. Is this readable enough, or should I increase it? Increase it. Okay, that's gonna be interesting exercise too. Okay, I did remember the shortcut this time. Cool. So we have the main function. Is this readable enough? No. Okay. Let's try. No. Oh God. Oh yeah. Now? Better? Okay, cool. So that's that's an actual Besom program. We have the main function, which runs the Pulumi run function. And Pulumi run function has all the program that we want to deploy. This is the scope in which you have to build all the stuff. If you don't want to do something like def something using context. So if you want to avoid that, you can do this. It's not a problem. But if you want to avoid that, you have to put stuff into pulumi.run because context is available implicitly in that. So we create resources. First thing, we configure the hcloud, so Hetzner provider. We take some properties from SSH, from configuration, so SSH key successes because we need them to deploy stuff to well, you need to provide SSH key, the public one, to VM to be able to SSH to it and apply any other commands that you would like to run. So we have to put SSH keys. We then create those virtual machines here. And I'm cheap, so it's not a full cluster. It's just a single machine here. And you can see that we are using the provider to configure, to use a particular connection, particular account of Hetzner in this operation here. And then you probably know this. This is just, we are telling it to run all this stuff in parallel. Don't wait, don't run them sequentially. We have only just one node, so it's not going to happen in parallel anyway. So what we do later, we deploy the K3S cluster. We have some configuration. This is a component resource, so it's an aggregation of other resources in a logical whole. And it's basically done using commands. So it's a bit hacky approach. There is no official support for K3S yet. So I had to make do. So I built the solution on my own. And what it does is it basically just executes bash commands using the wrapping that Pulumi offers. So Pulumi offers a way to do such imperative, impure, bashy things wrapped into command resources. So what we actually get, and that's quite interesting, is that if we go here and check the platform prod updates, or rather, let's see resources. You can see those resources here. So you can see what was actually done and all those things. So insert GitHub container registry token that we need to pull containers from GitHub. We have it declared as a resource, as a command. Same thing is with restarting K3S leader after putting in the token. Basically that's it here. Okay, so going back to the code. So we run those commands sequentially. We can Pulumi works in parallel by default because all those operations are not very quick. So all those interactions with cloud API providers take a lot of time. So all the resources are executed in parallel. And if you want to let Pulumi know that you want some of the stuff to happen sequentially, there is an option, additional configuration option that allows you to tell, okay, wait for this to happen and only then run this command. If you have data dependency, so if we took something like a standard output and fed it into this command, Pulumi will know that it has to do stuff sequentially on its own. If things are unrelated, so you can think, let's say, deployments and services in Kubernetes, they are unrelated things. They have just connection on the labels level, right? So you can then tell Pulumi to resolve those resources in a sequential way by declaring that explicitly. So we run a bunch of commands to create the K3S cluster, blah, blah, blah. We then fetch the kubeconfig from the machine because K3S creates the kubeconfig locally on the machine. We adjust that. It's easy to do because we're using a full programming language, so we can just operate on that string here and replace values that were inside of the kubeconfig file just in our program, because we have access to all those values. We can run our normal code on them. And then we go back here. That's a useful property, useful effect that I do when I'm working with K3s, that I write the created kubeconfig file to my local file system, only to be able to just use local kubectl. So I can do this, and oh no, no. Oh, so I'm able to run kubectl. Oh, I'm not. Well, let's not worry about that. So at the end of the program, we create a stack. We feed all the stuff that we wanted to evaluate. Remember, this is pure functional programming, so if we want things to happen, we have to tell the stack that, okay, those are effects that you have to evaluate for things to happen. I mentioned that if you pass outputs that come out of another resource as an input to another resource that you create, there's a direct data dependency, and Pulumi is already tracking that. So to be sure that everything works fine, linting that is provided by Scala free compiler is enough. It just tells you that, oh, you have something that you haven't used. And if you have something that you haven't used, it's a no-op. So normal rules apply. Things have to be evaluated to be used. OK. So this is the platform. The next thing is the site. And site is also boring. There's nothing really fancy happening here. It's basically a functional way to declare Kubernetes manifests. But we can see first interesting bit here, and that's an API that I'm still trying to figure out how to do properly, because we pull values from another stack. We are using stack reference here to pull kubeconfig from the platform and to pull IP addresses of the nodes that were created in this first platform stack that we have run. Then we create the K3s provider to be able to talk with Kubernetes. We use the kubeconfig that we have pulled from the state of the platform stack, create a namespace, and then we go on and create all the other stuff that we need to create. So Nginx PVC, Nginx config map, and here you can see how the magic is happening with the fact that we can now access those sites. So the host property in Nginx configuration is just used as a parameter for root property. So that's how we create those sites in the folder, and we have routing to that. Then we have Nginx deployment. This is basically YAML, but it's typed, so it's much safer than you would have it without it. We provide the configuration and the Nginx content volume to be able to serve those sites that we have as static sites provided by users. We declare all those volumes. We declare that something, the configuration comes from config map, and the content comes from the PVC that we have created. We also have a helper pod, which is just a bash pod that we use to use kubecp to copy the files inside of the job that deploys the content that you have provided. Then the Nginx service that is necessary for routing, application deployment. Here we are using something that is actually quite interesting. If I do something like that, this module is using something called, oh, it's not bigger. Can we make it bigger? Do we have time to waste to make it bigger? Not really. Command plus. I don't believe that is true. No, it's not. Well, what it tells us here, can you see this? Not really. Well, it tells us that something is missing from the configuration. And this is actually important, because we're using module that I have showcased on the Scala conference in March, the module called Besom CFG. So it's a very tricky thing that allows you to declare configuration necessary for your application inside of your application as a case class. So you just create a case class and you derive a configured type class for it. And then this program, which is a separate Pulumi program, is able to reach into the container with the application and pull out all the metadata that is necessary to tell what configuration is required for this container to actually start. So we have a compile error because we have provided invalid configuration for an application. This would crash in runtime. But with Besom CFG, this is now safe. We can see on the level of infrastructural program that this deployment would fail in runtime. You wouldn't have a correct start of this application because you haven't provided all the configuration. So we can uncomment that, and now it's all fine. This deployment has to work because the configuration that you have provided is type checked. All the properties are here. Then we have readiness props, liveness props, all of them, not really important stuff. Application service for routing, and the ingress that I have mentioned before. So ingress is actually important because here we have the ingress that routes stuff with the wildcard subdomain approach, and here is the one that routes the top-level domain. The last bit here is configuration for Cloudflare, and we create the main ingress record just to be able to go to the Scala FYI site here. At the end, this is functional programming, so we have to return something. We tell the stack, those are all things that you have to evaluate for this thing to make sense, and we want to export some of the stuff to be reused by another stack. Now, the last bit is the template. So template is the program that is actually run by Automation API when you have executed the deploy button. When you press the deploy button, Pulumi Automation API checkouts Git repository that contains all those three things. So basically, this repo. It checks it out, and oh, wrong side? No, template, good. Then it uses one of the subdirectories that you have selected in the configuration and runs the Pulumi deployment inside of this program. Like I mentioned before, this is the part where we take all the necessary values for the configuration from the previous stack, so the platform and the application site stack. So we take kubeconfig nodes, we take the name of the namespace, the name of the pod that was the bash pod that we used to copy files, and then we declare some resources. So we use all the functional combinators that we have here to create a command that will put the files that we want to deploy on the local file system in a temporary directory. Then we use the command module again, this time to copy using the kubectl. That's a hacky thing. That's that's the Minecraft hatchet thing. We just use kubectl cp command. Can you see this, by the way? Use the kubectl cp command to copy things into the volume that is shared for the Nginx. And then the last bit that is necessary, we create the top-level domain, the subdomain actually, to route the traffic to your website, the website in question being here thing. So we create a record that is the DNS-A record, and we pass the subdomain under the main ingress host, which is Scala FYI. At the end, again, we return a stack. We tell what has to be evaluated and things that we want to export. And that's the whole bit. So the whole infrastructure is declared in Scala. Now there's the last bit, which is the application. The application itself is a very, very trivial Scala app. You can see here the Besom CFG module. Can you see this, or is this too small? That wasn't on purpose. I mean, maybe. So we have configuration file. It derives the configured type class. Then we resolve this configuration. This method throws. It kills the program if your configuration is invalid. So we can continue evaluation of our application with the being sure that this configuration is correct, because it wouldn't work if we didn't inject this configuration via Besom CFG. So at the end, we just start HTTP server. There's a handler. It doesn't do anything very fancy. It just declares the endpoint create site, takes a form body, create site request, and uses automation API. Okay, this bit is important. So this is the automation API usage. Oh my God, how did this happen? I mean, thank you, Metals. Sorry, IDE was too eager. I didn't need that import. Okay, be gone. So current state of automation API is that it is in preview, or rather shaky experiment level. It works, as you can see, but there is no proper public API yet. That's something that we're currently working on, and we want to stabilize that. We want to have automation API working with all the FX systems that we currently have in Scala. So for now, you can see for comprehension on either monad, but that would be possible to use with Cat's effect, with Zio, maybe even Kaio also, if we have support for that. So what this API does at the current level, which is internal, is that you just basically run all the steps that you would also run in your command line. The steps are very, very similar. The API that we're going to offer in proper release of automation API will be more declarative and less imperative, less like a list of correct steps that you have to do. So the important bit is here. This is the Pulumi app. So upsert stack. And we tell it to use the Git repository with the template folder. And then we just declare that this is the project Scalify with the runtime using Scala. That's the password that I used. Don't blame me. I'm going to destroy that in a minute. And we also pass some additional configuration that we have declared in the stack that we want to use. So Cloudflare token, zone ID for Cloudflare, and the content and subdomain that the user has provided. We configure that all, use Pulumi app, and then it's done. Okay, I think that's all. So we can go back to slides. And you can take a screen cap of the links if you're interested. And I think we have a minute of time for questions.
Thank you so much. Do you have any questions? Yeah, we do. There you go.
What's the major benefit of using Pulumi resources instead of interacting with cloud provider API, Kubernetes API directly?
Well, first problem is that how would you maintain state? How would you know what was created if you were using those APIs? Because if you look at this from the fundamental perspective, what Pulumi does for you and what Terraform does for you is that they call those APIs. So the value is not in calling APIs. The value is in the fact that they track information about what has been created, and they allow you to search in the state for things that might be of interest. So there are things that are features built on Terraform, built on Pulumi, that allow you to search in those resources. It's actually quite nifty. I have to say that I'm always amazed how this works. We have several deployments now, right? Provided that we didn't kill Pulumi with our presentation. But we can see all the resources that we have deployed, all of them with their types available in this dashboard, and we can search for them. So the value added is, well, first thing is you have a declarative API. It's not imperative anymore. You declare what things you want to have. You have a preview feature. So when you run Pulumi preview, or you run Pulumi app without Y modifier, so without just acknowledging things, it will show you this is the stuff that is going to happen. If we go to the stacks here and we select any stack, oh, things didn't deploy there. Oops. Well, it's a POC. Maybe Pulumi failed. It wasn't me. So you can see that it did actually do a full analysis of what is going to happen. So it did check. I don't see preview, but that's probably because I have deleted preview to make it run faster. So it would show us what are the differences going to be if we apply those changes that we have made to the code. You wouldn't have that if you just called APIs. You can see what differences were introduced on any Git commit to the infrastructure as code. Well, and in the end, there is also Pulumi registry, which is a very big repository of packages that are available for Pulumi. Current state with Besom is that when we started a year ago, we had support for, I think, 4 packages. We currently have support for the full public registry of Pulumi. So everything that is mentioned here can be used. And there's a lot of stuff that is very common, like AWS, GCP, Azure, but there is also a lot of stuff that is niche, and you wouldn't find an API for that. You wouldn't find a library for that. So by using a tool that is aggregating all those features, you get all those features from declarative approach, state management previews, but you also get access to many, many more resources that you would usually have with APIs.
Do we have any more questions? Looks like that's it. Thank you so much.
Thank you.